Morning. Michael or David? Michael, nice. So we're building our dynamic secant line here, right? I've got my function set. I plot my first point A, f of A. That's in blue, right? In purple is my next point, right? And then I've got a distance between the 2 points that stays fixed, right? Because what do I want to do to H? I want to let H go to 0, and then I will not have a secant anymore. I'll have a, say it for me, tangent line. Yes. I'm calling this day 5. Day 4 was Monday. We didn't have class, but it's just easier to think of always Monday, Wednesday, Friday for me. So I'm looking at, and this is not my same function, I'm just going to put a function in here. I'm looking at A and A plus H, right? Where this distance is H, right? And I'm drawing the line between those 2 points, and I'm going to let H go to 0, right? So imagine H getting smaller, smaller, until I get right to my tangent line, right? Oops. Don't worry about that last green one. Oops. So, and you see my secant lines become the red line, right? So as H goes to 0, those secant lines become the tangent line. Yes, is everybody following? Good. We need to put our tangent, our secant line, our line on this, on Desmos, right? And of course, I'm going to use, and should be on your formula sheet already, I'm going to use what? Y minus y sub 1 equals m times x minus x sub 1, right? The point slope formula. And for us, our x1, y1, our first point was a, f of a. Right? So I've got my x1, y1 in there. Is everybody understanding that? But I need a slope, right? And the slope is pretty easy, right? It's f of a plus h minus f of a over a plus h minus a. And of course, that turns into, we did all this already, by the way, right? Over h, right? Yes, question?
So that would only be f.
Say again?
Would that be only f of a?
No, because I can't see inside machines, right? The first machine has got something different inside than the second machine, right? So I can't manipulate those algebraically. Remember, it's function notation. It's not, I'm not distributing there. I'm not distributing f. I'm saying put the value of a inside of the machine. Put $1 into the soda machine. Put $5 into the soda machine, right? Et cetera, et cetera. So I want to get this function onto Desmos. So I'm going to say m equals f of a plus h minus f of a. Highlight all of that divided by h. Why is it saying undefined right now? H is 0, right? So I'm really kind of dividing by 0, but guess what? It's actually 0 over 0, right? So I'll just move it over a little bit like that. Good. Now that I have my value of m defined, and don't let me go too fast. If I'm going too fast, slow me down, right? I am your Uber driver. I purposely try to hit potholes. You could ask me not to, right? That's especially you have a big cup of coffee or something. David, hey, you okay with moving down a seat? Is that okay with you? Nice, thank you. I answer all your questions? Email? So let's put in our tangent line. Y minus f of a equals m times x minus a, right? Quantity x minus a. And there's our tangent line. So you can move point A, the distance between the points is the same. You can move H, right? I want to use this to try and predict my slope of the tangent line at x is 0. So I want to try and predict when A is 0, what happens to the slope of my tangent line. So right now, what do you see in there? Slope of my tangent line, 0.5, right? As I move my tangent line, I'm going up to 0.7, 0.77, 0.8. You see, as h is going to 0, yes, you with me? As h is going to 0, what do you think? You can kind of predict it right away. With the way I have it zoomed at this moment, it looks like the sine curve is running, it's a straight line. And that's what we're doing, remember? We're saying, hey, let's get so close to it that any curve looks like a straight line. Right? I mean, we're pretty close to the horizon right now. Does it look curved to you? No. It looks like a straight line because we're close. I mean, in terms of the universe, right? So you can kind of see where is this going? Who's got the guess for me? You see the line where it's hitting? It's hitting at 0, 0 and at 1, 1, right? So what's the slope going to be there? 1. So as I get h going to closer to 0, and what's nice here is you could change your scale for h, right? Let's say I go between -1 and 1. Oops. And I go by 0.01. I go by pennies, right? So I can, oh, yeah, that's right. So I can get really close to 0 here, 0.15, 0.14, 12 cents, 11 cents, yes? And look at where my slope's going, right? At 7 cents, it's 0.999, right? So it actually gives us an interesting limit to talk about, our first trig limit. Oops, I want to do it on day 5 with a new page. Sorry. Well, how would I get the slope for the sine function at 0, 0 and at some other point, right? So this point is 0, 0. This point is x sine x. How do I get the slope there? How do I calculate it? Sine x minus what? Good, over. Beautiful, which turns out to be sine x over x. And we already know the limit as x goes to 0 of sine x over x, because it's the slope, is what? 1. I don't hear very well, just as a reminder or for the new students. You got to yell at me. So if someone in the back said 1 already, and then I heard someone else say 1, you both should feel like you have credit. But because I'm mask on, so I can't wear my glasses, so it's blind. I can't hear. This ear is going from rock and roll. This one is just getting there from old age. So just yell at me, okay? This is a nice limit to do, also numerically. Question 1?
How did you get the y minus f of a equals m?
Yeah, that's our line from Algebra 1 or Algebra 2, the point slope, right?
I mean, like, yeah, I think that was the point of equation, like, why is it like, with the x minus?
Yeah, so then the question is, what was the first point I made? A comma f of a. And so I put that in instead. And then I'm figuring out my slope for my theta point.
Right, but I feel like I've never seen that publicly.
Yes, you have. In fact, divide by x minus x1. Divide that, this one, right?
Oh,
You see it?
okay.
You see it?
Yeah.
It's slope.
Yeah, okay, got it.
I need 2 points for slope. So for this particular line, I only need 1 point. I need a slope. I need a slope and 1 point, right? Point slope equation. Nice, nice. Beautiful. So this is all the understanding we need. This is an interesting limit. I'll come back to that later, but you want to memorize everything we have. Remember, when you take your quiz today, you may use a single sheet of paper, front and back, right? Anything you want on there, inspirational lyrics, right? Anything. So you got that one page to play around with. Hey, morning. What's your name? Oh yeah, no problem. Yeah, scroll up. Yeah, you're welcome. Sebastian, have you been here before?
Yeah.
Were you just missed you missed Friday or
No.
you were here? Were you here Wednesday?
Yeah.
You were here the Monday before.
Yeah.
Every day.
Yeah.
All right, I'm sorry. Oh, you were sitting in the front. Yeah, but that one's not working. If you're okay with that seat, it's yours. Okay. That one doesn't work. The keyboard. There's a spot here if you want to sit up front. There's a spot there in the second row, there in the second row, wherever you want. Okay, good. Thank you, Sebastian. Once I get much better with names once I start handing you papers back. That's when I really start to get them. So you just got to forgive me right now until I start. I need that kind of physical interaction to be able to really remember things. For some reason. Okay, so let's go back to section 2.1 and let me open our textbook real quick. Daniel, I have to give you the WebAssign code. Did you get into a WebAssign class already with the other class? Okay. Dan, you have a phone with you? Will you just take a picture of my class key and then do the old switcheroo later? You didn't pay for your book yet, did you?
No.
Good. And again, update on the book. It's definitely $55. Do not pay to 110. If you paid to 110, I'll get you half your money back. But wait for me, okay? We made a 5-year deal with them. We said, okay, we'll use your textbook if you give us a price break for 5 years. So and you'll see my homework compared to the rest of the school. There's my homework. It's only 24 homework assignments. They are not graded by me. They are not part of your grade. They are optional, right? But you need the $55 charge to get the textbook, okay? Could you do it without paying for anything? Yes. You can go to the Math Learning Center and use the textbook there. You can go to the library, use the textbook there, right? So if money's real tight, me personally, I want to be able to throw the book when I get mad, upset, frustrated. I want to throw the book. I don't want to throw my computer. So I'd rather have the physical book. And it will be used for Calc 1 and Calc 2. Daniel, right there, take a picture of that Montgomery College 1486 3848. Got it? Thanks. Oh my God, so slow. So slow. Okay, here's our book. So I like for our first homework assignment, due Monday, in section 2.1, I think I had given you suggested problems up to 9 or 7. What was it? Up to 9? So I will like you to hand in let's hand in number 9. On Monday, yeah. Number 9. So it's different than I have posted on Blackboard right now, but it's okay. I'll change it later. Number 9, handed it to me Monday. Yeah, question? Want just number 9. I want you should do all of the odds, but I don't care how formally you do it. This one should be a work of art when you turn it in. I'd like a graph, and you see that they're doing a sequence with 0.5, 0.05, 0.1, 0.01. I'd like you to extend mine, really, what do I want for sequence? 0.1, 0.01, 0.001, gas station money. At that point, you should know what you're going to. You can do another one anyway. You can do all that on Desmos and then paste or print or redraw by hand, right? It should, what? No. Yeah, rough sketches always, yeah. So you're doing secants to get the slopes of the secants, right? You're doing secant slopes. Then you are doing a guess at the tangent slope, but then you're going to do your limit to get me the actual tangent slope, right? And I'll show you what I mean by doing number 7. In 2.1. Yeah, 2.1, number 9. That's our only homework due Monday. I might add 2 or 3 more problems on Friday for that homework on Monday, but at least you can get this one done as soon as possible. If you have a homework problem that takes more than 1 page, you can finish it on the back. But otherwise, I want every new homework problem started on a brand new page. I have paper for you. I like to say, don't try and save paper. It'll hurt your ability to do problems. So I like to say, kill a tree, pass the class. And then when you're all making $100,000 a year, go plant some trees somewhere for Calc 1. You'll have to plant 2 for Calc 2. Okay? All right, let's work on number 7. It says I have the curve y equals ln of x. And I have a point on there, 1, 0. Yes, everybody with me? I'm going to Desmos to start my problem. Yeah. What? No, ln of x. Yeah, hold on. So when you're working on a test, it's nice to kind of have, for every problem you work on, to have a Desmos window open. Once you know you have the problem right, kill it, of course, right? Once you know you have a problem, right, don't think about it anymore. Okay? But if you're still in doubt on it, you can just open a new window, new Desmos window for a new problem. So I've got, I like to use the f of x notation, so I can say f of 1 or something like that, right? So that's ln of x. This should be a good friend of yours from pre-cal. What's my domain? What's the, all what? All real numbers? Positive, yes, positive real. So not, 0 doesn't work here either, right? And we have our point 1, 0. They gave that to us. Nice, I can see that. And I want an arbitrary point on this curve, right? I want an arbitrary point on this curve. Oh, this is not a good one for me to do for your prediction, sorry. It's okay. So my arbitrary point is going to be a, comma, f of a, or ln of a, right? And I want to calculate that secant slope. Question, are we okay? I'm pretty lazy. I don't want to have to, we don't have to calculate slopes like we did in Algebra 1 class, right? We can use the technology to calculate our slopes. And of course, we know our slope here is what? M equals ln of a, or f of a, I'll do it that way. F of a minus, what's the y value here? 0. Don't even need to write that, right? No, I'm going to do it anyway. Divided by a minus 1. How are we doing? We okay? Now, looking at the problem, let's go. Let's see if I go 175%. Got smaller. 200%. I don't know. Can you see it? Can't slide it. Damn it. Sorry. Can you see it okay? But take a look at what it's doing. Remember, I'm trying to get as close to 1 as I can, right? Try to get as close to 1 as I can. Here's the numbers from the left. Which numbers are from the left? What numbers here are from the left of 1? 0.5 is definitely to the left. That's the one I think is stupid. But then 0.9, 0.999, 0.999, those are the ones that are left. They don't have to be consistent with it because they'll see the pattern there. You'll see that the 0.05 I put in won't help my pattern. But 0.9, 0.99, 0.9999, sounds like I'm speaking German, right? And then from the right are the other ones. Again, 1.5 won't help me with the pattern, but the 1.1 to 1.01 to 1.001 to 1.0001 will. So I can do all of that on Desmos and then translate that back to to our homework, right? When you turn it in. So to get that table on Desmos, I'm in my piece where I'm calculating. I go to the gearbox and I pick, damn it, I can't do it.
Is that a different problem?
No, I can't do it. Oh, I know how I can do it. So I have to do it with a drag here. I have to do this one with a drag. So I'm going to try and drag h to be 0, right? So, and I need up to 0.001, right? So I've got to change my scaling and I got to do my steps by 0.001, yes? And I got to start at 1.5, don't I? Oh, thank you. Oh, you're right. Thank you. Yeah, sorry. And I still can't do the table, so I'm going to have to do it with my... Okay, I'll try that. Oh. Yay! Nope, still doesn't. That's all right. So I'm going to have to do it with A, right? I'm going to have to do it with my arbitrary point A, and I want to make sure I get a scale of 0.001 because that's as detailed as the homework question is asking me. And I'm going to go from, because I only care about 1, I'm going to go from 0 to 1.5. Again, I'm just trying to make sure I get my A steps as close to what the book is asking me to do, right? Nice. So, did it ask me for a 1.5? Yes, right? So I'm writing that one down in my homework. Then it gave me 1.1, right? There it is. Yes? Then 1.01. Right? Yes, you with me? And then 1.001. Oh, did I lose that? No? Yeah. I didn't make my scale big enough. It's okay. You know what I'm talking about, right? Yes? So you don't have to do that calculation by hand. Oftentimes I'll see students doing it by hand. You don't have to. You could create this function. Here's the better way to do it. I'm sorry. I figured it out. Watch this. What's my upstairs function? So I'm gonna call it g of x. This is going to be my secant slope here, equals ln of x, right? Divided by x minus 1. This will let me do it finally. I go into my, everybody have that function written in? I had it at f of a over a minus 1, right? But this will allow me to do the table. I finally, with Autumn's help, I figured out what I can do to get the gear to work here. So I go to the gear, I go to the table, and I'm putting in the values. What did they say first? 0.5, right? Yes? And I'm saying that one's not going to help me much with my prediction. The next one was 0.9, right? 0.9, 0.99, 0.999, and you can see what's my prediction for the tangent. What's my prediction for the tangent? What do you think? Where are we going? Yeah. What? Obvious. If it's not obvious here, then you're dealing with a limit that doesn't exist, right? Or you just didn't go further enough, far enough. But I'm telling you, this gas station money, by the time you get there, you'll always be able to predict. Okay, so there's one extra step I'm asking you to do in problem 9. So I want to look at problem 9 real quick, okay? If I could just control, there we go. On this one, I've got what kind of function? Can you see it? I don't know if you can see it. I'm trying not to be cool with the eyes, but I can't control the book very well. You see the function? It's a parabola, right? And what's it doing? Opening up or opening down? Opening down, right? The t-squared variable is negative, right? The coefficient is negative. So I'm throwing a ball up in the air, or I'm throwing a box up in the air, or I'm throwing a pen up in the air, right? I'm just throwing it straight up in the air, and it comes back down. Of course, if I do that while I'm moving sideways, right, you see the parabola. Right? If I'm moving and I throw it straight up in the air, you see a parabola, right? So that's what's happening. We get a parabola. I want to do the same thing with the secant slopes. I think we can go further with this. 0.5, 0.05, 0.1, 0.01, 0.001, right? And then we should be able to make our prediction. But I want you to do one more thing with it. I want you to get the tangent function by taking the limit. Okay? So let me get us set up here on number 9. I'm interested in what's going on with the ball at 2 seconds, right? And f of x is equal to, I'm going to use x. I drink coffee, I don't drink tea, so 40x minus 16x squared. Of course, if we graph that, or better yet, if I factor it, what comes out of there? 8? Uh, 5 minus 2x, is that right? So I see it hits 0 and it hits 2.5. Right? You with me? Yeah? Good. I'm interested in the slope at 2. So I need 2 f of 2 there. Who's got that for me? Thank you. And I want to do a secant slope, right, to some point to the right. So the book is asking me to do secant slopes some point to the right. How far to the right? Do you remember the numbers I was saying? 0.5, 0.05 to the right, 0.1 to the right, 0.101 to the right, 0.001 to the right. Yes? So I'm getting, this red point is getting closer to the black point because h is going to 0, right? So we're going to come up with an x 40x minus 16x squared as our arbitrary point. Yes, you with me? Now, think about it. I want to know the slope at 2. The book is asking me to put in h values. So if the book is asking me to put in 0.1, that's an h value. What's the f value? What's the x value? The original point is at 2. But they want h to be 0.1 further away. So what's that x value? 2.1. So I want us to come up with the tangent slope. And we have this memorized, right? The limit as x goes to c, or x goes to 2, of f of x minus f of 2 over x minus 2 is the tangent slope. Say again? They're up on YouTube until I put them on Blackboard. Now, we've had a couple of versions of this already. This is a new one that I'm giving you, right? I'm saying the limit as x goes to c of f of x minus f of c over x minus c. Before we had the limit of f of x plus h minus f of x over h. That one is as h goes to 0. They're all the same, right? And the first one you ever saw was the limit as x2 goes to x1 is f of x2 minus f of x1. That's our regular one from like 8th grade, right? Our slope, y2 minus y1. These are all the same. When do I use which one? Depends. I don't really ask you to decide which one we're going to use. I'll tell you which one we're going to use. Okay? So this is going to give me my tangent slope, right? So this is I want you to add this to the problem, right? You with me? So what do I get? This is the limit as x goes to 2 of star. Someone tell me what star is. What's my function? What's f of x? 40x minus 16x squared. What's my f of 2? Yep, minus 16. All over. Nice. And you can already see that the problem is when x is 2, right? Because what happens downstairs when x is 2? I get a 0. I'm hoping I get a 0 upstairs as well, right? This is an 80, right? Yes? This would be what? Guess what? The upstairs is 0 as well. 0 over 0. So when I get a 0 over 0, I'm looking for that replacement function. What do you see I could do here? Yes, so I've got a negative 16x squared plus 40x minus 16 over x minus 2. I could factor it, I could long divide, I can synthetic divide, get my replacement function, and it should match up to my prediction from part B. Exactly. How we doing? Nice. Feels better than Friday, right? Yes. Better than Friday. Yeah, it just takes a little bit of time to get used to it, but the next thing we're going to do will help quite a bit. Okay. All right, we ready to move on? Yep, I'll wait. No rush. Nice. Okay, here we go. This is the fun part for me. The rest of chapter 2 is kind of boring for me, so I'm going to skip it for now. I'm going to move on to chapter 3. And what we're going to be talking about is derivatives. I've got a bit of ADD, so it's hard for me to do things the way the book wants to do it, especially when I get bored. But this is really the most important thing for us in Calc 1 is derivatives. The most important thing for us in Calc 2 is antiderivatives, how to undo a derivative. And so what am I talking about? So I'm kind of doing some of chapter 2, some of chapter 3 here. Don't worry, I'll take care of you. Just like I did limits before I did 2.1, right? Because I can use the knowledge of limits in 2.1. They kind of want you to discover it. I don't care about discovery. I want you to be able to do the problems. So derivatives, what we're talking about is f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h is the derivative of f. If it exists, of course, it has to exist. The limit has to exist. And it gives the slope of the tangent line at any point x f of x. So like in the problem that we did before, we said f of x was ln of x. It turns out that f prime is 1 over x. The derivative is 1 over x. You're going to memorize all of these. Put them on your formula sheet if you can't memorize them. And if you remember, we had the ln of x. We were interested in the point 1, 0. Can anybody tell me now the slope of that tangent line? One over what? 1 over 1, right? Because the x value I'm interested in is
Oh, because the X
exactly. So this particular derivative is very hard to find. You can't really do it until the end of the effort. You're going to wait on me. You're going to trust me that it's this function. Okay? I'm going to give you shortcuts that you're going to memorize. Get the step 2 or put them on your form sheet that you want. Okay? But we're going to be able to derive most of it. This one we're not ready for. We need a couple of tricks. But I want you to see. Remember we were doing a prediction for this one, for number 7? Right? And I got 1.00005, 1.00005, right? And we predicted 1. Well, if I know the derivative, I know the slope and the rate. Okay, here we go. Our first derivative. Yes? Well, that was our first one, but we didn't actually do it. We're going to actually do this one, okay? If you've taken calculus before, or you might know a lot of these shortcuts already. But if you haven't, this one you should be able to tell me anyway. If I tell you that f of x is 2x minus 1, who can tell me what f prime of x is? 2. 2. It's the slope at any point. And we know, of course, that 2x minus 1, right, always has the same slope of 2. So in my formula for the derivative, I should get f prime of x equals 2. All right, here we go. This is tricky, okay? So when can I test on this? Quiz on this? Monday, right? Today's Wednesday. You need the day to practice, the day to ask questions, and then I can assess. So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Notice in blue, I have a 2x minus 1, but my x is replaced with, inside a parenthesis, very important, x plus h. Yep. The rest of it is minus f of x, minus the original function, yes? And divided by h. This is a difference quotient, right? So I have a couple of choices here. I could keep writing limit, or I could decide that this is the limit as h goes to 0 of like star, and then I can work on star separately. You can see we're just doing our limits again, right? So I have 2x plus 2h minus 1 minus 2x plus 1 all over h. So I'm just manipulating this piece, right? You agree with me? I'm just doing algebra on that. Yes?
So you got 2x plus 8 minus 1. Like one part of it, like, what's the formula?
Yeah. So remember, f prime of x is f of x plus h minus f of x all over h, right? Oh, the limit as h goes to 0. So I'm first plugging in the x plus h to the function. Then I'm saying subtract the original function. Yeah, Dave? David? So this minus?
No, in the equation, 2x plus 1, because we have x top is 2x minus 1.
Let me put numbers. 1, 2, 3, 4. Where are you?
3.
Yes, and 3.
2x minus 1, why is that equation 2x plus 1?
I didn't. I didn't change it. It's 2x minus 1. That's the original function. No, I don't see a plus anywhere. This plus?
No.
There's no other plus. Good. Autumn.
Talking about the equation wall where I'm.
Yeah, but I distributed the David, I distributed the negative. Okay. I want to see what goes on here. Oh, the 2x's go away, right? The 1's go away. And I'm left with 2h over h. Oh, and that becomes 2. The h's cancel, right? So I've got f prime of x equals 2. We now have our first shortcut. If f of x is an mx plus b, then f prime of x is what? M. Nice. This one's too easy for me to give you on a quiz or anything, right? So, but you're going to memorize it, and we're trying to understand it. At any point on that curve, right? At any point on that curve, I should be able to pick an x value, and I'll get the slope of 2. And obviously, when I plug a 3 in here, right? F prime of 3, well, there's no place to plug it. There's no x. There's no placeholder. So I just get the answer 2. What about if I plug in negative 1? What's the slope? 2. It's obvious, right? No? Yes? Yes, question. Daniel.
We use the tangent slope formula to get the derivative.
Exactly. Yeah. Good. Let's do a tougher one. Well, let's do an easier one. If y equals 3, 1, 2, 3, what's the slope? 0. Obvious. Any constant is a horizontal line, right? And notice I'm using y now, right? Isn't y the same as f of x? Yeah. So y prime, f of x, f prime of x, right? The line you see, I'll use a bunch of different languages, different notations. So that one doesn't take really much time at all, right? F prime of x is the limit as h goes to 0 of what? 3 minus 3 over h, right? Remember, h never gets to 0, right? You with me? H gets really close to 0, but 3 minus 3 right away is 0. So 0 over 0.1, 0 over 0.01, just put them in.
What is h usually used there?
Say again?
Like for the derivative, like what is h usually used there?
What if h is what?
Like what is h like usually used at?
Yeah, h is the difference between my 2 points. So h is there, and there, and there, and there. But it's, again, what's the slope when I get to h is 0? 0. Horizontal line. Slope of 0.
When do you get that?
When you're finding the derivative. So the next one will make more sense. This one's so easy, you're like, what the hell? We don't even need to do anything. And that it causes confusion. When things are easy, we as humans usually try and make them complicated, right? Anybody agree with that?
Yeah.
Yeah. So we want to try, when it's easy, it's hard just to accept a lot of times in life. And kind of, I'm asking you to accept and think so that you really understand what's going on. Let's do another one. Here we go. If f of x is x squared Who knows it already? What's the derivative? Nice. And you'll have these memorized pretty damn quickly, okay? But let's do it the long way first. Let's do it with a limit. So f prime of x is the limit as h goes to 0. And don't let me go too fast. If I'm going too fast, slow me down. I need x squared, right? But instead of x, I'm going to use an x plus h. You with me? So you can see my x squared there, but I use parentheses, and I fill in with x plus h. Because that's the formula. Let me remind you of the formula again. F prime of x is the limit as h goes to 0 of f of x plus h. So you see I'm taking the original function, plugging in x plus h, minus the original function over h. Where did I get this from? The slope, right? The secant slope. So minus x squared over h, right? Everybody, make sure everybody's with me. Notice I'm using empty parens with the original function. You see this guy here as x squared, but it's not x squared anymore, it's x plus h point, right? So I'm looking at that second point of my third. Then back to my first point, right? So y2 minus y1 upstairs over h, which is x2 minus h. Yes, exactly. Well, I gotta FOIL, right? What's your favorite four-letter F word? No, it's not FOIL. So, but what do I get? Oh, sorry. I get x squared plus 2hx. What? What? Oh, okay. It's okay. I like jokes. Is this okay with everybody? X plus h quantity squared, right? X plus h times x plus h is an x squared, right? That's with an h squared, and I get 2hx. Usually we're in alphabetical order. Everybody okay there? Anybody need to see me do that on the side real quick? Yes? So I have an x plus h quantity squared, right? And that is x plus h times x plus h, right? And that is x squared plus an hx, again alphabetical order, plus another hx plus an h squared. So there it is, x squared, oops, plus 2hx plus h squared. Yes, you agree? Good. What goes away in my numerator? X squared. And in fact, listen to this comment. This is important. Every term without a factor of h has to go away or you get something wrong. Every term in the numerator that doesn't have a factor of h in it has to go away. At this point, if I let h go to 0, I get 0 upstairs over 0, right? And that's what we want, because we now know how to deal with that. We got to just work on a replacement function. Osmo, you okay? Did you take the Advil at the right time, like I told you? 250 milligrams right before, 15 minutes before class starts, and the headache won't happen. Some days we'll need 500 milligrams. I'll tell you when. Okay? So here we go. This is the limit as h goes to 0. And what's my idea? What did I tell you we have to do? Factor, right? So I can take out an h, and I get a 2x plus h, still over h. And you see here, I'm writing the limit every time. It's a pain, right? So we can do that little star thing or whatever you want. But now the h's cancel, so I'm looking at f prime of x is the limit as h goes to 0 of 2x plus h I'm ready. I'm at the wall. So what am I going to put in? H is 0. And there it is, 2x. Notice when I put the h in as 0, I'm no longer writing the limit notation, right? I'm already at the wall. There it is. There's no shortcut. Someone yelled out 2x, right? When I said that the derivative was, the function was x squared, someone yelled out 2x. So here's what they know. Here's what they know and what you're about to know. If y equals x to the n, then y prime equals n times x to the n minus 1. This is called the power rule. If I have x to some power, to get the derivative, I bring down the power and decrease my power by 1. You okay? Let's try one more. Then I'll take attendance. Then we'll get the hell out of here. Go have breakfast, right? Or hopefully you ate already, but what is breakfast? No. All right, one more. Yes, we okay? Not going too fast? Yep, 1 second. I'll wait. Yes, question? Yes, y prime is 3x squared. Good. Right? Bring down the power, reduce the power. And it should make sense why I'm reducing the power by 1. Why does it make sense that I'm reducing the power by 1? What am I dividing by? What am I dividing by when I'm doing this limit? Let's look at this version. No. I like that though. Yes. I mean, yes, but no. Exactly. That's what I'm asking you. Look at these top right corner. What am I dividing by? The first person or the third person. X minus x. I'm dividing by x. So it's got to read if I'm doing with x cubed, and I eventually go divide by x, I'm going to have to end up with some kind of x squared. All right, let's do a tough one and then we'll quit. I want to take attendance before you leave, but let's say y is square root of x. Anybody have it already? So if y is square root of x, anybody know this one? Yes, yes, good. So 1 over 2 square roots of x. Here we go, f prime of x, yes? What's the first thing I do with my function? Well, it's square root of x, right? But what do I put in? Oh, I forgot my limit, sorry. Limit, as h goes to 0. I put in what for square root of x? Square root of x plus h minus the original function, all divided by h. This one I'm gonna choose to call this guy star or asterisk or whatever or hashtag, and work on that function separately. Anybody see what we're gonna do? Conjugate. Conjugate. I used to be in the back of the class yelling, conjugate on with it. I got kicked out a couple of times. So square root of x plus h plus square root of x all over itself. Why do I do that? So that I make sure I'm multiplying by what? 1. I'm allowed to multiply by 1. I'm allowed to add 0. And we'll do it many times in the next 2 semesters. Count 1 and count 2. Multiply by 1, add 0. So all we really do is nothing. Which is nice. It's the perfect class for me. Right? I'm doing nothing right now. Multiplying by 1, it doesn't change anything. Calista, what happens upstairs? What happens upstairs?
It turns into, X plus
Nice minus. Beautiful. Be careful if that second term is a multi-term, you gotta keep your parenthesis around it, okay? Downstairs we're not gonna touch it. Why? Why will I not bother distributing the H downstairs? Eventually it's gonna cancel, right? So why bother? You're gonna have to factor that out later. You wanna manipulate where you put something in play. So meaning, oh shoot, I forgot about the quiz. We're gonna do it Friday. I forgot. So I'm gonna manipulate where it will do something. And so what happens here? X is canceled, right? Remember what I said? Every term without a factor of H in it had better go away, or I'm in trouble. So the X's cancel. I've got H over H times the conjugate. Now my H's cancel, yes? You with me? So I get my replacement function of 1 over square root of x plus h plus square root of x. And that's my replacement function. How are we doing here? Am I going too fast? Okay, I'll slow down. Now tell me. You upset that I forgot about the quiz? No? Good. Yes. I didn't. I never, I just said I have h times this. I'm ready to finally do my limit. F prime of x is the limit as h goes to star. I'm going to plug in my h is 0 now. Yeah, question. Question what? Yeah, but don't let me go ahead. Where are you? I no longer have my limit notation there, so I'm going to put h as 0. Kind of a waste of time, because I already know this is 1 over square root of x plus square root of x. And how many square roots of x are there? 2. And there's my derivative. Believe it or not, this was a power function. Yep, so square root of x is also x to what power? Half power. So I can do my shortcut by bringing down the power and then subtracting 1 from my power. So I get 1/2 x to the minus 1/2. A negative exponent means move it to the denominator, right? And of course, that's a square root. So sometimes I'll say to you, use your shortcuts. Sometimes I'll say, find the derivative using a limit.
Why is
Yes.
the square root of x?
Say again?
Why is the square root of x?
Yep. What line?
Line 1.
Why did I do square root of x plus h? Because that's the definition. Remember, I've got 2 points, right? So think about this. Here's my square root function, right? I got an x, square root of x, and then I have some h later. I have x plus h, and out there I'd have the point f of x plus h. Sorry, x plus h, comma, f of x plus h. And remember, I'm doing a secant slope, but I'm letting h go to 0. So y2,
Oh, so square root of x, square root of x.
yes, oh, sorry, this, yes, square root of x plus h is better here. Nice. Nice, let me stop my recording.